Okay, hopefully you had a chance to get some coffee or something during the break. I'm going to go ahead and introduce our next speaker. Travis is going to be speaking about the DMA, MIMI, and DMLS, and linearized matrix, and a bunch more things. So please give him a warm welcome.
Hello. So I'm Travis. I'm Director of Centers Development here at Matrix.org. That primarily means that I get to deal with a lot of the interop and DMA stuff. So that's what this talk is about, is the Digital Markets Act, the more instant messaging, we'll get to the acronym later. I forgot what it is, but it's MIMI. There's also MLS, the messaging layer security and decentralized variation of it, linearized matrix, and just the interop in general between all of these different things. So, very brief recap first. Digital Markets Act is the DMA. So it requires what they call gatekeepers to open up their platforms for other similar providers. So we have a primary interest in messaging for Matrix. And so, we are spending most of our time trying to figure out what that is, but the DMA covers quite a bit more. It covers everything from browsers to app stores to that sort of stuff. But so far, only WhatsApp and Facebook Messenger have managed to actually become gatekeepers. Everybody else has avoided the requirements and has either convinced the European Commission that they aren't gatekeepers or just doesn't qualify, because you do have to either have a certain amount of revenue or a certain number of users, that sort of stuff. Critically, though, with the messaging side, all of the encryption that you have on both sides of the sort of interop channel here needs to be maintained. So you can't decrypt and then re-encrypt messages. You have to actually maintain that encryption all the way through. So in Matrix, we have this concept of bridges, which typically do that decryption and then re-encrypt and then send it along to the other side, either to Matrix or to WhatsApp in the sort of DMA use case. Back at FOSDEM, we talked about more of this protocol conversion kind of idea, where we instead have a process that actually sits there and doesn't actually re-encrypt. It proxies the encryption all the way through end to end. So we have to maintain that exact same encryption. The sort of update now is that gatekeepers are required to actually do a lot of this stuff already. As of March of this year, they have to actually start opening up their APIs. And these gatekeepers have started opening up their reference offers, or the legal agreements that actually define what interop is. And so far, it's looking like they're just opening up their existing APIs, which is not great, because those existing APIs can just change, and then things break, or you have a maintenance burden on your end. So ideally, a common, hopefully open standard can actually help here. Obviously, Matrix is an existing open standard. It is quite large, though. It has state resolution, it has authorization rules, it has all sorts of stuff in it that may or may not be easy for an existing gatekeeper like, say, WhatsApp to implement and provide out to their sort of partner organizations here. Linearized matrix is something that we created back around FOSDEM that is a little bit smaller. It's a little bit easier to understand. It's a very, very quick to write. We wrote an implementation in about 24 hours of actual coding time. And it's very similar to MIMI in this sort of room model there. I'll cover that in a bit, just so we're just kind of getting through the brief recap of what's sort of happening around the space since about FOSDEM, so about February of this year. MIMI is the More Instant Messaging Interoperability acronym, which I definitely didn't forget at the beginning there. So it is a working group at the IATF, or the Internet Engineering Task Force. They are trying to specify a standard for modern interoperable communication. They are trying to learn from, say, XMPP, which is also an IATF standard, and also the 14 other variants before it. Linearized matrix was originally proposed as a possibility for this working group to consider, and it is just a simplified version of matrix. It works in interoperability and MLS settings, MLS being that encryption, and it just kind of works. It's It already exists as an implementation, but it doesn't quite have all of the MLS components in it yet. And so compared to, say, Matrix itself, which is fully featured, existing open standard, including messaging, it covers more communication as well. Like you can have IoT, VoIP, and all that stuff. Hopefully that's been made clear from the previous talks as well. And so yeah, like just comparing the two, linearized Matrix is a lot more simple. Messaging layer security, or MLS, provides security and group membership guarantees. So it's making sure that the members are actually part of the room, that they have legal devices, that they actually have a proof of those devices as well. That also became an RFC since February. So it is now RFC 9420. If you feel like reading a few dozen pages of standard specification, that is how MLS works. They're currently working on actually getting the RFC for the architecture document, because MLS is split into two physical documents. You have your protocol and your architecture. So RFC 9420 is the, I believe, the protocol. DMLS is similar to MLS, but it changes some of the actual way that the keys are sort of distributed. And so it's something that we've invented. We've called it decentralized MLS because we want MLS to work in Matrix. MLS doesn't normally work in a decentralized environment on its own. It does require a sequencing server. It requires all sorts of details to make sure that commits, which are just changes to the actual state, are put in order and can't be mutated or changed sort of after the fact. Decentralized MLS, or DMLS, is the idea of being able to change that. So you actually have a state resolution in the client that takes these divergent branches and recombines them back down to a common state. In terms of actual interoperability, we have multiple sort of problem domains that we have to worry about. So obviously there's the encryption. How are we actually securing those messages? That is MLS in this sort of example. But it could also be Ohm, Megohm, or any other double ratchet, for example. We also have a content format of like, what does a message look like? MLS doesn't specify what the message looks like. It just says it's the implementer's concern about what that should be. And so we have to define what the actual content format looks like. For Matrix, this is just your mroom message, your event types, those sorts of things, contained within, say, an mroom encrypted. We might want to also use extensible events here if we were to continue down the idea of like actually formally building out a lot of the stuff. Extensible events is something, again, that Matrix has invented, with the idea of being able to represent one message in all clients without having to worry about whether or not it's renderable or having support for that event type. So there is effectively some fallbacks that you can render those events as. We also have an authorization policy, so simply who is allowed to do things, like can this user invite, can this user ban, can this user redact, those sorts of things. Can you send images, can you send other messages? And possibly even down to further interop things of can you create invite links, can you respond to that invite link? That is all considered under policy, or the authorization policy even. Matrix currently defines this in a number of ways. We have that state resolution, we have those auth rules, we have all sorts of mechanisms to make sure that events are actually allowed and the power levels are being honored and all that sorts of stuff. Mimi is considering something called role-based access control, or RBAC. There is an alternative of ABAC, which is attribute-based access control, which is slightly different, where you instead of a role containing permissions, you just have flags put onto a user. So can this user redact, true, false? Can this user send a message, true, false? That sort of stuff. We also need a transport in terms of actual interop. We need to send all of this information between at least clients and servers. Those servers might be very different sort of places. So this talk primarily spends most of its time talking about the actual encryption and a little bit of the policy. The content format and transport are completely up in the air, both for the theoretical idea of Matrix plus DMA interop, as well as Mimi. Mimi is actively in conversations about what those details should look like. So with Mimi, we start getting into hopefully what things have changed since back in February. So at the last FOSDEM, which was just back in February, the working group was just putting the finishing touches on the protocol. So on the Matrix side, we were actually working on the actual protocol components, whereas most of the sort of other core contributors were working on the architecture and the sort of formatting and the actual types around that sort of stuff. And so, yeah, those turned into adopted documents by the working group, which isn't to say that they are accepted in specification. It is just to say that they exist and the working group has decided that this is the way forward. And so there has been extensive feedback from the working group on this. It's gone back and forth quite a few times since February, and even earlier then. But yeah, it now uses something called MLS AppSync, which is a proposal within the MLS working group to basically make membership operations and other operations atomic, or at least confirmed within the MLS group state. So when a client membership is updated, you also have to update the user membership at the same time, because you don't want a user to be part of the room but not their devices, or a device to be part of the room but not their user, because that creates problems. And so yeah, it just wants to update it at the exact same time. The working group is also currently working on something for identity and just general discovery of how do you actually find these users on WhatsApp or Messenger or wherever else, and how do you report those users back to either the original providers or to the hub server in the case of Mimi, because abuse is a thing. While the working group doesn't talk about actual abuse mitigation mechanisms like anti-spam or anything like that, it is still important to at least be able to report those concerns. How that works with, say, a reduced metadata mode is interesting. Mimi is currently theorizing a lot about this because the current protocol documents do actually specify quite metadata heavy constraints. Like you have identifiers everywhere. It's very revealing to the server, even though it is an encrypted group synchronization protocol. And so with reduced metadata mode, which may or may not be an optional sort of tag on as we continue to explore these things, the server just doesn't see as much of the actual metadata. As Matrix, we are continuing to participate in these discussions and these ideas. We're bringing them back to Matrix where we can. We're thinking about them, and eventually they'll turn into MSCs, particularly for, say, like the reduced metadata mode stuff, because Matrix does have its own fair share of metadata as well, and it would be nice to remove quite a bit of that as well. So the Mimi room model looks a lot like this. It uses a hub and spoke sort of fan out where you have one central server that is processing all of the events, all of the messages, and then redistributing them out back to all of the sort of following servers. That also means that the hub enforces the policy. It is the only one that gets the authority to actually do this. The other servers just have to assume that the hub is acting in good faith. They can validate it in some cases, but they can't validate it in all cases. And particularly in Mimi, all of the provider servers, which are called follower servers, have to talk to the hub. They can not talk to each other directly, except in a few very rare circumstances. This is obviously not great because it is centralized. It creates a central point of failure. It makes sure that the room is in one place. And yeah, you are reliant on, in this case, provider A enforcing policy directly. So Matrix is decentralized. All of the servers have a state resolution algorithm that ensures that everybody is participating in the exact same way, at least in theory. And Matrix is also full mesh instead of having to go through a single server to reach anybody else in the room. Encrypted messages, though, still go directly between clients. The servers can't inspect the contents of the message. They can just see an encrypted blob of basically garbage. So if we start talking about MLS and Matrix, though, we start getting into some heavy work in progress here. Some of these ideas were created last night, so there is a little bit of sort of up in the air here. There is a little icon there to show you, hey, we're not like seriously proposing this yet. We have a lot more work to do on this. We have to think about it a lot more. So before we get too much into that, we have to consider what MLS off the shelf looks like. So MLS on its own, you have to bring your own delivery service and your own policy and your own concept of users and your own content format. And that includes all of your transport, all of your fan out, what do messages look like, who is authorized to do what. All of that you have to bring yourself. You have to design that. It is left completely as an implementation detail. And so you have to write a standard on top of the MLS standard to actually define all of this. But you do get cryptographic group membership, particularly for devices, because each device within an MLS tree is a leaf node. They have their own key material and all of that. But you don't have that for users, because users have multiple devices, typically in these sorts of environments, especially in Matrix. And so we want to make sure that at least the devices have cryptographic proof that they are part of the group, that they were allowed to be in the group, and that they have the key material to continue participating in that group. MLS also replaces device lists from Matrix. If anybody has seen their devices randomly disappear over Federation, that'll be a device list. They can get out of sync pretty easily, and so MLS replaces that, because if you're not part of the cryptographic room state, you're just not there. And so you actually have guarantees, and you can rebuild a lot of that state as well. Application messages, which are basically just anything that isn't state information. So your messages, like your text messages, your images, your whatever, those would just go into an application message. They can be out of order, unlike commits. So when you're adding somebody, that is a commit to the actual MLS group. The commits do need to be in order, because otherwise you end up with state divergence, and that causes problems, which is what Matrix aims to solve with state resolution. But the application messages can be out of order, only up to a certain degree though, because if you get too far out of order, then you start creating gaps in your timeline, and then you might lose keys, and nobody has that key material anymore, and there's no way to really rebuild it. Although, speaking of key material, MLS doesn't really give you conversation history. So in Matrix, we have this idea of being able to be invited to an encrypted room and see the history of that room from before you joined. In MLS, the way you do that is you just resend all of the messages, which means you also have to re-encrypt all of those messages, which is obviously not great, but that is something that might be able to be worked around or worked within the MLS working group on. So that's MLS. Linearized matrix off the shelf is very much like Mimi. You have a hub and spoke model still, so you still have that very centralized server, because that is just how you simplify it, particularly out the state res part of matrix. It is a linked list rather than a DAG. That's, again, just for that simplicity, so you don't have to resolve conflicts within a tree. You can just simply keep adding things as you go. Linearized matrix is also theoretically encryption agnostic, but the way that it's currently defined and documented is it's more aware of MLS. So it has some of those APIs that are actually useful for MLS, but a double ratchet like Ulm or Megalm could also be applied to linearized matrix, just with a little bit of work, particularly on the transport side. So that's where you start re-adding your device lists and your two-device messages, that sort of stuff. Linearized matrix also just deals with events, just like matrix. It's very important for something that has matrix in the name that it deals with events, so it at least looks the same. And so we want to maintain those user concepts as well as events and rooms and these sorts of things. We have also tried to design it so that way it works with matrix, at least in theory, either with direct protocol conversion, as I sort of mentioned earlier, or with just being able to kind of work through some sort of other algorithms, which may appear in a couple slides here. So MLS and matrix, or linearized matrix, becomes a little bit more sci-fi, because again, these are sorts of ideas that are coming up like literally yesterday. So instead of having user membership derived from the group membership, we create a superset. And that is simply so that way we have the capability of having users with 0 devices. Because from a product point of view, you want to be able to log out of all of your clients and still be in the room, but you just might not receive messages, or you might not be able to decrypt those messages. And so in order to maintain the actual cryptographic room membership guarantees, another client must bring your clients back into the room, particularly when you log back in. This also means that if the server just decides to inject a user into the room, you don't randomly start encrypting for that user or that user's devices. Those devices have to be brought in. And so as far as the cryptographic room state is concerned, there's a user with 0 devices participating in the room. They see nothing, even if they might have actual real devices attached to them. And so, yeah, that gives us cryptographic room membership, at least in theory. We would have it. We don't have it at the moment. It is something that we desperately want in Matrix. But we still do need sequencing. We still need to make sure that those commits are going through, which is why we would base it off of linearized matrix, at least at first, so we can get that sequencing very early. But we can do a little bit of a trick where we can send all of the application messages just full mesh. So we get this partial full mesh instead of having to run everything up to the hub and then everything back out. We can just simply run commits up to the hub. So this is like your add and your removes for the actual membership state, and then bringing everything, they were bringing all the messages in themselves just kind of around the other servers, much like Matrix today. We would have to modify the client-server API. It's very important that we maintain at least some semblance of the existing client-server API, because it already exists. It's quite large. It would be difficult to rewrite. And so we would have to add concepts for MLS, because we don't need, say, the keys query or keys claim endpoint anymore, but we do need to deal with things like key packages and that sort of stuff. So we do need to send those around, and we do need to deal with those on invite in particular, because your invite sequence now becomes, you try to invite a user, you get a key package for that user, you then do a bunch of MLS, and then you commit that out to the server, and now the user is part of the room. Unlike today, where you just call the server and say, hey, invite this user, and they're part of the invite state. The federation side would change, though, just because linearized matrix doesn't deal with DAGs, and so it doesn't need any of the complexity of the server-to-server API. So we can narrow that down quite significantly. If we then expand the scope a little bit and just keep going into, say, MLS and matrix, though, now we're really into just this is an idea that may or may not work territory. So when we start dealing with matrix, we start dealing with a DAG. And so we have room splits that are possible, where partitions between servers that go offline, and it just causes issues. And so one option is, if we still have a hub server, then we can continue the conversation only on that side of the partition, but the other side is just stuck and they can't communicate, which isn't great, because if you do want to be able to communicate on both sides of a partition, which is generally the case, you do still need some form of ordering because of MLS. So possibly a raft-style consensus election can be put in place here to elect a hub server on both sides of the partition. They continue their actual conversations, and then when the actual partition is healed, you fix the room by reinitializing the group state, which is an MLS concept to basically say, I don't know what's happened here. Let's just try to start again. Like, let's just create most of a new group without actually creating a whole new group. And so this can help heal those group conflicts. We might have to resend some messages back and forth, but we can also, just rely on those elections to try and figure out who the new hub is, particularly when the partition is healed. Consensus can also theoretically help with a lot of other areas of matrix. Let's say there's a disagreement within the actual algorithms of matrix itself about what the current room state is. That is an issue that can be easily fixed by the consensus of servers saying like, the current room state is this. And then you just do that. You have to fix whatever your database is to actually represent that. And then you can continue on with the room. So it would be a helpful sort of fixing mechanism outside of MLS as well. But yeah, this is all theoretical. Consensus would really, really be helpful, but we just don't have it today. We also don't really know what it would look like. Raft is one option, but there are a few others. But yeah, overall, That's kind of where we're at with DMA and MLS. So we are just kind of thinking about a lot of this stuff. We're trying to think about what consensus would look like, what MLS would look like, possibly what DMLS would need to change to actually represent this stuff. I have a little bit of time for questions if people have them. Kitsune?
I guess the changes in client-server API for MLS plus metrics are mainly around devices because the device lists.
Yeah, so with MLS, you just don't have device lists, but you do have to communicate up to the hub server that like, hey, I have a new device, or I've removed a device, that sort of stuff. And so you have to be able to commit that back and forth. Right. But there's also changes to the actual key infrastructure as well. So like we don't need keys claim or keys query anymore because that's all infrastructure that's handled as part of MLS. And so you end up being able to, or you just have to modify APIs like join and invite to pass around key packages instead. Yeah.
Is it going to be a part of Matrix Rust SDK eventually sometime?
Possibly, yeah. It's something that could easily be part of the Rust SDK. It would potentially be easiest to represent that or do these changes in the Rust SDK because then you also have multiple platforms that you can test this with, multiple network conditions, that sort of stuff.
Sorry, and the last question, the MLS reinit, because I haven't heard about it before, using reinit, would it be possible to effectively emulate a DAG?
So yeah, reinit
is taxing for that?
Yeah, reinit is very similar to a room upgrade for like matrix concepts, where you effectively say everything past this point is just
reboot.
Yeah,
okay.
Yeah. But reinit does it in a fancy way, effectively, where instead of creating a brand new MLS group and referencing it sort of backwards and forwards, it just says like, hey, just stop here, create new key material, try again.
Okay, thanks.
Yeah. Other question?
So obviously, cryptographic room membership would be great, and that would help prevent a home server from making up a user or a device and inserting them into an encrypted room. Does it seem tractable to insert that into Megalm at all, or is MLS really the direction we want to go for that?
Megalm is theoretically possible with cryptographic room membership. There are a few MSCs for that sitting in the spec proposals repository. I have not read them up to date myself, but there is quite a bit of state that you need to maintain between that, and MLS just gives you that for free because you do need to make sure that the devices have a way to cryptographically prove that that user or that device was allowed to be in the room and that they have the key material in order to do that. And so with Megalm, you start to have a lot of different keys flying around, and you have to start worrying about which is signed, that sort of stuff. Yeah.
Other questions?
Or concerns or complaints. I take all of them. All right. Were there any in the chat by chance?
Let me check the chat. I don't see any, which means that you must have explained everything perfectly well.
Perfect.
And nobody has any questions.
All right. I left a little bit too much room for questions then. But if people do have questions either throughout the weekend or anything like that, feel free to track me down or visit one of the rooms. Thank you.
All right.